very first time. I am Miss Smith or Dr. Smith from Extra Time Tutoring, and welcome to Extra Time Tutoring's Grade 1 Roadmap Seminar. And I was wanted to first tell you a little bit about us. So we are a center that specializes in tutoring and preparing students for biology and chemistry exams from fourth form, fifth form, and sixth form. But one of the main objectives of our institution is not just to assist in helping you to pass the subject, but it's really for students who really need the subjects for the career choice. And they not only need them, but they need them at a high level. So they need to get a grade 1 to matriculate into very competitive areas. A lot of the students, especially medicine and stuff, and they want to get scholarships and they want a distinction. So usually those are the type of persons that we really want to push to achieve their full maximum potential. We want students to not only pass the subject and not only to get a distinction, but to be amongst the students on the merit list in Jamaica, amongst the top 100 in the country, and also amongst the top students in the Caribbean. Why we stress this? And we stress that whatever you do, you should try to master it. And that is a principle that I would suggest to you in anything you do in life. Try to master it. Once you are doing it, it may not be something you're going to use afterwards, but when you're doing it, give your best, do your best at it, because people remember you for having done your best. So when you do very well in a subject, even though you're not going to use the subject again, the fact that you did well in the subject leaves a statement, leaves a mark. So anybody looking at your report will see that you are the type of person who you excel and you master anything you do. And that is the type of attitude I want you to have. And that's what we are really preparing students for. So we found that there were three things that were important for a student to really do extremely well. Like we have had students who have been amongst the top in the Caribbean, and those students would have topped Jamaica. And what we found with these students was that they had done 3 essential steps. There was the preparation step, which is where you first educate yourself about the subject that you are going to sit in an exam. And I don't mean the topics that you're learning. I'm talking about educating yourself about the curriculum that you are going to be participating in. So we found that one students had that preparation step, and then the step now where they actually start learning the content as content coverage and examining and exam papers. You practice exam papers, and then the final step was revision before the exam. Once you executed each phase, found that you would do very well. But more importantly than anything else was this preparation phase, which is what we're doing right now by having a discussion with you to walk you through the curriculum for CXC chemistry and just let you see how you're going to construct your own grade. So CXC doesn't give you a grade, guys. You earn the grade you want. And so you must know what CXC is going to test you on to be fully prepared. So let's get into it right now. So for CXC chemistry, chemistry is concerned with substances of which matter is composed and its investigation of their properties and reactions and the use of such reactions to form new substances. So essentially you're learning matter. Anything that takes up space has mass, is matter, solid, liquid, and gas. And your job is to learn the properties of matter so you can investigate and predict its properties and its behaviors, and then you can turn around and manipulate matter. And that is essentially what you're being prepared for as a chemistry student. If you're going to be pursuing chemistry to the highest degree, you are being educated as to how matter behaves until you get to the top of the chain and you can manipulate it to behave how you want it to behave. And that is essentially how chemists and polymer scientists, they design polymers with new features and new characteristics that we have never seen before, because they knew how to manipulate substances for them to have the properties they wanted them to have. And this is the foundation to get you there. So I have a video I want to show you here. Why are you studying chemistry? Just to give you an insight as to how far this science can go. Just a moment. Okay.
The world is currently facing some major challenges: protecting the environment, developing sustainable energy, maintaining public health, and securing food and water supplies. Chemistry is the central science, the science concerned with all physical matter. We need creative chemists to find solutions.
Take climate change, the biggest challenge to human and ecological survival. Chemists strive to gain the knowledge needed to protect our planet. They observe the subtle changes in the environment, like ocean acidification, atmospheric pollution, and the buildup of marine plastics. Chemists at the University of Plymouth are at the forefront of research in this area, informing policymakers on how to protect our futures. They are not just in the lab, they are found working in extreme environments across the Earth, from the tropics to the remote deep oceans and the frozen polar regions. We know that sustainable supplies of energy are needed to replace our reliance on fossil fuels. Chemists at Plymouth create chemical models to innovate industrial processes. They work with nuclear reactors and develop catalysts that can recycle waste into new materials and energy. Chemists collaborate with industry to help businesses improve their operations on a local and global scale.
At Plymouth, I'm working with a team that care about these issues. I'm learning the hands-on techniques that industry and employers seek. I want a degree and a career that support change. I believe that together we are the innovators of the future.
And what she's saying there is exactly what I want to take away from it. The persons who you see in this video started off at the level where you are at now, which is to learn the fundamentals of chemistry. And they have spent years studying it to the level of the university where they are now able to manipulate matter. And she said something very critical. She said that she's studying it so that she's able to offer solutions that businesses seek and that environment seeks. Even one of our biggest challenges that are facing right now as a species on this planet is the whole problem of global warming, where we have excess amount of carbon dioxide in the atmosphere that we're not able to absorb. Right now, we have scientists working around the clock, thinking about how to do carbon sequestration, which is how they can develop a chemical reaction to absorb the carbon dioxide from the atmosphere. Chemistry is going to solve that problem. So I don't want you to just confine yourself to thinking, oh, this is a subject they say I have to have. But there's a program that you're going into and they say I have to have chemistry and I just need to pass it. No, you are being exposed to a body of knowledge, and I want you, whatever body of knowledge you're learning, and I want you to get this principle. If you are forced to go into a class to learn about crochet, and you have no interest in learning crochet, and you have no interest in using crochet, once you are doing it, do it and master it and do your best at it. Because what you're doing is training yourself to be disciplined and to master anything you devote yourself to. So the fact that you are going to sit the exam means that you have devoted yourself to doing it for whatever reason. And for that reason alone, to give it your best, because that will be a statement about you. All right. So now, the CXC syllabus for chemistry has 3 sections, A, B, and C, and they do test you on all 3 sections. So even though something like organic chemistry takes forever to finish because it's so long, you still have to remember it's only but 1 section. So you can't spend all of your time preparing for it and ignoring the other 3. Neither, and a lot of students get into this trap where A and B is where they get stuck. They really don't get to section C, right? Because of time constraints and they don't get there. But you might know A and B very well, but you never learn section C, so you're not going to be having a full coverage of the syllabus. So you have to make sure you are competent in all 3 sections of your syllabus. Now, some parts of the syllabus should have been covered in grade 10 if you did it in grade 10. There are some persons who try to do chemistry in a year. I don't personally suggest it. I don't suggest it. So persons ask for it in a year. I said, no, the only way I can see you doing it in a year is if you're gonna be doing the grade 10 topics at the same time you're doing the grade 11 topics. So whereas even at our institution where we prepare students for CXC, we do allow persons to do CXC biology in a year, because CXC biology is heavily based on knowledge and comprehension. So if you can be taught the topics, you can study very well, you can manage it in a year. But chemistry is heavily based on use of knowledge. And with knowledge, things, you have to take time to absorb things. You can't rush teach chemistry because it's not knowledge and comprehension that they're testing primarily, it's use of knowledge. And also, these foundational topics that were covered or should have been covered in grade 10, these are the pillars of chemistry. You cannot, and I repeat, you cannot do well in section B or C if you never completed section A properly. Because you cannot be, basically, this is chemistry, and I consider it to be I consider it to be the most difficult of the sciences. A little bit more difficult than physics, and even the passes show that every year the physics passes are better than chemistry. Because physics they have separate topics that are not related to each other. So you can study your physics topic on electrolysis, not electrolysis, on electrochemistry or electricity. And then you go and you study the other one about kinetic energy and kinetic movement. And the movement has nothing to do with electricity. So you could do poorly at one topic and do very good at the next one, and you're fine. Chemistry is not like that. Chemistry is literally like you're building a house. It's literally designed like that. You're building a house, and by the time you get to inorganic chemistry, and by the time you get to the end of organic chemistry, what you are putting on is the roof of the house. You're putting in the furnishings of the house. But you have to start off from the foundation and build one step at a time. And the way the chemistry syllabus is structured, it starts off with the simplest topic, but that topic is important to understand the next one. So guys, states of matter is important for you to understand mixtures and separations. Then you learn atomic structure in order to understand everything else. Atomic structure, you need to understand that to understand periodic table. You must understand the periodic table to be able to do structure and bonding. You need to cover these three before you can understand mole concept. You must cover these the first 5 topics before you can understand acid, bases, and salts. And it continues. So every single topic is leading you to the next one. And by the time you get to acid, bases, and salts, number 7, you cannot competently do this topic unless you master the first 6 topics that came before. So this is the challenge now that faces us with the chemistry, because when it is that the students come, or even say I'm meeting you, some of you are saying you're starting classes with us in 5th form, and I'm very concerned now about what took place in 10th grade, because I know, especially, and I just had the 10th grade seminar and I stressed it, and I want to stress it to you again, because if your foundation is shaky, some work has to be done on the foundation. The topics of atomic structure, periodic table, and structure and bonding are the 3 most important topics in chemistry. Mole concept is very important as well. I would even put it in, but if I had to pick 3 topics, I'd take 3, 4, and 5. If I had a choice of 4, I'd put in the mole concept. But you cannot succeed, you cannot excel, you cannot understand the rest of the topics coming in section B and C if you never master these 4, especially structure and bonding. That one will just stump you for a very long time. If you can't do structure and bonding, you cannot write equations. You cannot write equations, you can't do acid, bases, and salts. You can't do electrical. Everything that comes afterwards requires an equation, and you cannot write an equation because you never did structure and bonding properly. So the problem with chemistry is that once you get to topic number 5 and that foundation is shaky, it's going to topple. The entire thing is going to be toppled down. You can't skip a topic. That's why the topics are taught in a certain sequence. The sequence is a must, or else you're not going to understand the other topics that come. So you might be in a situation where you did have a shaky start for grade 10. You may need to go back and do some revision for it, some remedial work on it, because you cannot swat the chemistry. It cannot be swatted. There is no shortcut to chemistry, right? And so I want to just leave that with you. Not that chemistry is so hard. It's not that any of these 1 topics are difficult, you know. Atomic structure by itself is not a difficult topic. Mole concept is a little bit different because it's a unique set of mathematical calculations for chemistry, but it's not that you cannot manage the topic by itself. The problem comes is that you're dealing with a web. You're making a puzzle, you're building a building. That's what chemistry wants you to do. It wants to build you up to a certain level. And they know that by the time they come and they test you, by the time I give you a question from electrochemistry, this one question in electrochemistry, which is the 9th topic. Once you do that question properly, I know the other 8 topics were done good. So that's how chemistry is. You're just growing and growing. And so when they test you on something later down, they know that you have covered the rest of it. So with that in mind, your approach to chemistry is going to be different from all the other subjects. You want to, even if you're going to be starting 5th form now, and you know, if you feel that the 4th form is shaky, please go back and read the textbook on these areas here. Shore up your knowledge in atomic structure, periodic table, periodicity, structure and bonding, mole concept, acid base. You have about another week or so to read it over, or you have to schedule some time that in the week while you're learning the 5th form topics, you're learning the 4th form topics. Please, because I know that it's not going to work. All right. Now, once you start the 5th form year now, it's assumed that you would have covered these topics and covered them sufficiently. And even though there are many topics in the syllabus, in 10th grade, most schools don't go beyond the first 7. Spend a year cementing these 7 because they know that once these are cemented, you are going to flourish. But in grade 11, when you start, like in our program, which we are starting next weekend, we start off in grade 11 at oxidation and reduction. And this topic is you're going to start off with equations, and you have to know what group substances are in. Just for you to do this topic here, it is going to expose whether the foundation was good. Because by the time you start here and I say to you, I give you an element like, for example, nitrogen, and I say to you, nitrogen has 5 electrons and it needs 3 more electrons, so therefore it has a valency of -3, or it has a charge of -3 or an oxidation number of -3. And I'm assuming you understand what I mean, right? That it is in group 5, and you might wonder, why is it in group 5? Because it has 5 outer electrons. Why does it have 5 outer electrons? Because it has 7 electrons in total. It has 2 on the inner shell and 5 on the outer shell. So essentially, you have to know the fundamental principles just to be able to start surviving when we start this topic right here. So I'm saying if you have any concerns about your grade 10 knowledge, especially for these 3, atomic structure, periodic table, and structure and bonding, address it. Address it, spend some time, secure some time, get a textbook, read it over, and address it and review it before you start the 5th form topics. So in 5th form, when you start chemistry, you would have been continuing in section A of the syllabus, but you would have completed at least 7 topics in section A in grade 10. So you would be finishing up the other 4 topics in section A, which is oxidation and reduction, electrolysis, rates of reaction, and energetics. All right. So those are the topics now to finish in section A of the syllabus in grade 11. Then now you have to progress to the section B, which is organic chemistry, and then section C, which is inorganic chemistry. So I must say to you that the bulk of the work for chemistry is really reserved for grade 11, and grade 10 was spent slowly building a solid foundation, because if without the foundation, it's not gonna work. All right, so I have some applications of some of the topics from these section A, like for example, periodic table and periodicity. I want to share this video with you.
I know you
So you may wonder why does Bill Gates has a periodic table in his house, which is an extremely expensive asset, guys. And he shows you what each element is used for. So these are all the elements on this planet. A lot of even the microprocessors that he makes uses these elements. But the critical thing is that knowledge of the properties of elements allows you to find a use for it. And you allows you to manipulate it, which is basically what he did. But these 90 odd elements that are natural and 26 are man-made, he doesn't have the man-made ones. Everything on this planet is made from these elements. So if everything on this planet is made from 106 substances, and you spent the time learning the properties of these 106 substances, then and how they interact with each other, then essentially any piece of material you're presented with, you can predict how it will behave based on the substances it was made up of. And that's what chemistry is equipping you to do. All right. So then now in the rest of section A, we said we're going to do in grade 11, we said we have electrochemistry, rates of reaction, and energetics. Electrochemistry is basically learning how we can use chemical reactions to generate electricity. Simply put, by choosing the right chemical equations, the right chemical reactions, we can cause those reactions to occur and generate electricity in the very process. That's what it's all about, right? So we are going to be teaching you how the properties of elements and how we can combine them to generate electricity. But in this case, really, we're not generating electricity. We're actually going to use electricity to break down substances. But we can reverse it and generate electricity. But we're going to do the opposite. We're going to use electricity and we're going to change matter. Remember, chemistry is all about the manipulation of matter. So we are going to learn how the application of electricity can change a substance and we can predict it. So everything that you learn in chemistry, we teach you the principles and then we show you how, after we have learned the principles, how we can manipulate and predict what's going to happen. Also, the next topic from section A that you're going to do in grade 11 would be the importance of reaction rates, which I have here. Why are we learning this topic? As I said, nothing you're learning in chemistry is just for the sake of writing on a book. What we're teaching you are principles that are being used in industries and countries all over the world at a very high level, and we're teaching you the principles of it. So a reaction rate is basically how fast a reaction goes. And once we teach you the principles, then you will learn how you can speed up or slow down a reaction that you want to slow down. For example, things which are slow may need to be speeded up. Things which are too fast needs to be controlled. And we learn how we can manipulate temperature, pressure, concentration, surface area, and catalysts to affect the speed of which a reaction occurs. So after you have done, and the next topic is energetics. I didn't put an application for energetics, but that's the next topic here, energetics, which is looking at the energy changes that are associated with reactions. So when you do a reaction, how much energy is going to be given out or how much energy is going to be absorbed. Some reactions absorb, some reactions give out. You will learn how to predict and how to calculate that energy. That's energetics. Once you get to energetics, that's when you end section A. Then you go to section B, Introduction, which is organic chemistry. So the entire section B is based upon organic chemistry. And then also, guys, what we do, well, how we do it at our center here is we spend the first couple of classes teaching you the principles of organic chemistry, because organic chemistry contains mostly carbon and hydrogen. And you would have already learned about carbon from early in 10th grade when you learned about the periodic table. But there are some specific things that carbon does, which is unique. So we have to teach you a separate set of rules about carbon compounds and introduce you to it. And once you get that introduction down pat, usually the rest of organic chemistry is a breeze for you. And I find that our students, once they get the introduction to organic chemistry, they actually like organic chemistry. Usually students hate chemistry until they get to this point and they like it and they find that it's manageable. And fortunately for you, a good amount of the exam is based on organic chemistry. So it simply means that you may not be so strong in section A, or section C, but you're very good in organic chemistry, but you know enough of the other two sections, and you can still manage to get through. So let me show you this video on the application of our knowledge of organic chemistry, or the introduction to organic chemistry.
Introduction to Organic Chemistry. In the past, scientists classified compounds on the basis of their sources, and they formed two main groups of compounds: organic compounds and inorganic compounds. Organic compounds are obtained from living organisms. For example, carbohydrates are obtained from plants, proteins are obtained from animals, lipids are also obtained from animals. Secondly, inorganic compounds are obtained from non-living things. For example, salts like table salt, sulfates like calcium sulfate, nitrates like potassium nitrate. These all compounds are inorganic compounds. Later, Berzelius presented vital force theory in 1809. This theory states that organic compounds are synthesized by living organisms and it cannot be prepared in the laboratory. For example, according to this theory, carbohydrates like sucrose, C12H22O11 is only synthesized by plants. We cannot prepare them in the laboratory. Secondly, proteins are only synthesized by animals. Also, we cannot prepare them in the laboratory. They believed that God-given power is present only in living organism, which is responsible for the synthesis of organic compounds.
All right, so you'll see that organic compounds are special compounds because they're primarily made up of carbon and hydrogen, and they are made and found mostly in living organisms. So it's really the chemistry of living organisms, and so it operates with a different set of rules than how other substances operate. So that's why you have organic chemistry and you have inorganic. Organic deals with substances found mostly in living organisms, and they operate by their own set of rules. And the substances that are not found in living organisms are usually inorganic, and they operate by another set of rules. So essentially, the chemistry syllabus would be learning the principles first in section A, then learning the rules governing this branch of chemistry known as organic chemistry, and then learning the rules for inorganic chemistry. So organic chemistry has a lot of subtopics, but it really just has three big topics where you learn the sources of hydrocarbon compounds, and then you learn an introduction to the rules of organic chemistry, and then you learn, after learning the rules, how organic compounds react. So you're going to learn another set of reactions right here. So this is just showing you when it comes on the sources of hydrocarbon compounds, that's when you're going to learn where we get oil and natural gas from and how we extract it and how we purify it. So you're going to spend some time learning that. And this is just showing us a column that purifies oil, crude oil, and breaks it up into many different fractions or components. So for example, we have a refinery in Jamaica, it's Petrojam. We buy oil from countries like Venezuela, maybe even Middle Eastern countries. And then we separate it using this column, this tower, and we get many different products from that crude oil. We get fuel oil, diesel oil, kerosene oil, petrol, cooking gas from that one crude oil. So you're going to learn about this as well. And then you're going to learn the principles of the reactions for organic compounds. So you can see how they are going to react. For example, we're going to teach you how to draw these compounds between carbon and hydrogen and how they react with other substances. So you can predict what you're going to form and what you're going to observe. So we're going to learn all these reactions, and we have different categories of compounds. So we have different and you have this is one family, alkenes, and this is why organic chemistry takes so long, guys. Even though it just looks like it's just three topics, this part here, reaction of carbon compounds, takes the longest because there are five families of organic of carbon compounds you're going to learn about. You have alkanes, which is this first category here. Then you have alkenes, which are those which have carbon double bonds. Then by the time you get to alkenes, alkenes have 8 reactions, and you have to learn the 8 reactions that alkenes they can do, and you have to learn the reaction that alkanes can do. And then you have alcohols, and then you have esters, and you have acids. So basically, by the time you study the reaction that each of these families can do, you end up learning probably about 25, 30 reactions. And you have to kind of remember them. So that's why the organic chemistry takes so long. But once your foundation is solid, you actually will enjoy it and you'll do very well at your organic chemistry. This is a video I want to show you about how the knowledge of organic chemistry can be used for us to make soaps. Let's look at this. So guys, I'm not going to show you all of it, but let me just get to where the soap was finally made. But the point of this, why I'm showing you this video, and here is a bar of soap that was finally successfully made. You are going to learn how to make soap by learning organic chemistry, and you're going to understand the reaction that created the soap. And it is created from a reaction between alcohols and a carboxylic acid. So organic chemistry is a very exciting area. As I said, usually it's more friendly because it has its own principles. You still have to know the fundamentals, but usually even if you're not that very strong, you can manage with the organic chemistry. Once you're given the rules of organic chemistry, you can manage it quite well, even when your foundation wasn't so strong. But you want to strengthen it, the principles of chemistry, because you're going to need it for inorganic chemistry as well. So you're also going to learn about polymers in this section B here, and you're going to learn about the synthetic plastics, which we all interact with polymers every single day. Our clothes are made from polymers, our bags, rubber, even in our body, DNA is made from a polymer. The wood is made from polymer, wool, the frying pans, everything right now is made from polymer. So you're going to learn what are polymers, the different types of polymers, etc. So once we are done with section B, then the last section of the syllabus is section C, which is inorganic chemistry, which has 6 topics. You learn about metals and their reactivity and their uses. You learn how to extract metals from the earth. You learn what are the impacts of metals on organisms and on the environment. And then you learn about non-metals. And finally, qualitative analysis, which is how to identify the ions you may have in a sample. So that would complete the entire syllabus, section A, B, and C. So I have some things I want to show you about section C, some applications of the knowledge of section C.
This is MSJ Chem. In this video, I'll be looking at extraction of metals. Most metals must be extracted from their ores, which are found in the Earth's crust. Here we can see the ores of mercury, aluminium, and iron. The method used to extract a metal from its ore depends on its position in the activity series. In this table, we have metals in order of their position in the activity series and the method of extraction. The reactive metals potassium, sodium, aluminium, and magnesium are extracted by electrolysis of molten metals. The less reactive metals, zinc, chromium, iron, and tin, are extracted by reduction with carbon, carbon monoxide, or reduced by a more reactive metal. And the least reactive metals, such as copper, silver, mercury, and gold, are extracted by heating the ore, or they're found as native metals. In this video, we'll focus on metals that are extracted by reduction with carbon, carbon monoxide, or reduced by a more reactive metal. A metal that's higher in the activity series can be used to extract a metal that's lower in the activity series. Aluminium is higher in the activity series than chromium. Therefore, aluminium can be used to extract chromium from its ore. In this reaction, the oxidation state of the aluminium is changing from 0 to +3. This is an increase in oxidation state, which is oxidation. The oxidation state of the chromium.
All right, so we're not going into too much detail there. I just wanted to show you how knowledge of the chemistry of the metals will tell you how to extract the metal from the Earth's crust. And that's essentially what this topic is going to be about. And we learn the chemistry behind it. When, for example, in Jamaica, we have bauxite, and bauxite contains aluminum. We learn how we can remove the aluminum out of the bauxite, and that's chemistry and that's extraction. You have to learn that in section C. All right. So now, if you look at completely know what you must do in chemistry, you have 11 topics in section A. Section B, which is organic chemistry, is 3 topics, but really and truly it's divided into 12 subtopics, and there are 6 topics in section C. So in total, for the entire syllabus, you're looking at 29 topics in chemistry to prepare for. Now, if you consider starting this weekend to the end of April, you're looking at 32 weeks, or call it 34 weeks that you have from now to the end of April. And unfortunately, in some of those weeks, you're not going to have class, like in the December break and Heroes Week and Easter break. That's like 6 weeks gone. So that leaves you with about 26 weeks. This should have been 34. So that leaves you with about 26 teaching weeks left. But really and truly, you do need about 34 weeks to complete all the topics in the syllabus. And I'm talking about you can cover all the topics in 34 weeks, but to be honest, the grade 10 topics needed a little bit more time, which is why I said I don't suggest anybody do chemistry in a year unless you're doing your grade 10 and grade 11 topics at the same time. And it can't even be done in a way where even if you start off with a grade 10, you're going to have to go through at a faster pace. If you're trying to get it all done in a year, then it means that you're going to end up having to do grade 10 topics at a greater speed. And the important thing, though, is that in chemistry, especially for the first part, it's not about speed. You actually have to go slow to give it time to absorb. So when I have my students, we go at a specific pace. I know that I want you to spend 4 weeks on a topic. Yes, I could have done the topic in 2 weeks, but then it wouldn't absorb, it wouldn't percolate through your brain the way I want it to percolate. And I'm talking about those fundamental topics. Once your brain is quite set with that, then the rest of them, you can learn them faster. Like, that's why you have so many topics in grade 11, because you can learn that you can absorb them faster now because the foundation has been laid. So that even out of the 29 topics, the bulk of them are done in grade 11. Right? So that's why I personally don't push to get it done in a year. There needs to be time. with the first set of topics. Then, guys, you have your school-based assessments, which CXC has included because they want, in the course of the syllabus, that students will acquire knowledge, skills, and attitudes in experimental skills. So for CXC, the amount of labs required over the 2 years, there is a minimum of 16 labs that are required. And these practicals must include these topics. The labs must be done on these topics, or must include. You can do other labs outside of these topics, but these topics must be included. So there has to be a lab that was done on separation and mixtures. All right. There has to be a lab that was done on acid, bases, and salts. There has to be a lab on redox reaction and electrolysis. One has to be done on qualitative analysis. One has to be done on volumetric analysis. One on rates, one on energetics, and one in organic chemistry. These are the 8 fundamental topics that CXC says are core topics that must have labs done on them. You can do labs on other subjects, other topics to make up the 16, but these topics must be included. And as I said, guys, one of the ways to have mastery is that as a student, you have to be aware of your curriculum. You cannot just go blindly and just depend on the teacher to say that the teacher is doing what CXC wants me to do. You cannot do that. You have to double check, right? Because as I said, sometimes you might get a new teacher. Sometimes your teacher leaves in the middle of the school year and you are without a teacher for some weeks and a new one comes, and this new one is just to get oriented and trying to hurry up and catch up. And sometimes they don't do everything. So I'm saying, if you were keeping abreast, you could have said, Miss, but we haven't done a qualitative analysis lab yet. And you know that if you don't put in the qualitative analysis lab, you're in trouble with CXC, and that can affect the entire grade. So I want you to be aware of what you're doing and what you're doing to add your grade together, because you are the one scoring your own grade. It's not, no, CXC is not giving you a grade, right? It's a 2-year assessment you're doing. All right, guys. Yes, guys. So the labs now are done over 2 years, or some persons are doing it in a year, they do it in a year, but you want to make up a total of 130 marks. And they're assessing 4 skills in chemistry: manipulation and measurement, how well you will manipulate or how well you handle yourself in the lab with the lab apparatus and lab procedures, safety procedures as well. So the teacher will look at you and observe you and give you this grade. You must at least do 1 lab in grade 10 on this skill and 2 in grade 11. So this is what the teachers we look at to know what labs and how much to give you. And you have observation, recording, and reporting. This is where you are assessed to see how well you can report information about an event that occurred, how you write and describe the event if you're using proper English and the right tense, and how you draw your graphs and your tables, etc. Planning and designing is when you have to design an experiment to solve a problem or to answer a question. And analysis and interpretation is when you're given like graphical information, like a graph, and you have to be able to interpret information from that. So at the end of the 2 years, the school will submit this sheet and will say how much out of the how much for grade 10 you got. So how CXC does it is that they group skills together. So in grade 10, they put manipulation and measurement, observation, recording, and planning and design, and they put that together. And they also add it to the manipulation and measurement and observation and planning and design that you did in grade 11. So they put all of this together as, they call it P3, and P3 comes up to 90 marks. And then they look at your use of knowledge and analysis and interpretation that you did in grade 10 and that you did in grade 11, and that comes up to 40. But when you add when you add everything together, it comes up to 130. So you're basically trying to see how much of 130 marks you can get from the lab. Now, as for your grade, your final CXC grade, this is how CXC calculates your grade. All right, let's just look at it. So there are 3 profiles that you get on your exam slip: knowledge and comprehension, use of knowledge, and experimental skills. So, and I want this to be riveted in your brain. The experimental skills comes mostly from the lab. So that 130 points that you're trying to get in your lab, they will scale it down to 30. So whatever percentage you get of the 130 marks will be whatever percentage you get of this 30 points that you can get here. But there is an experimental skill question that you must do on paper 2. So you get 30 points from the labs and 10 points from the question that you do in the exam. So what we have found though, is that persons might go in with a very high amount of this 30 here. So say, for example, you were able to score like 25 out of this 30, right? But you messed up on this one here. Well, you're going in a total of 25 marks and you're going to divide it by 2. And then you end up with like 12 point odd out of the total. I'm just saying this to say why sometimes students have very high lab grades and they go and they get a very low grade for experimental skills like a B or a C because they messed up the lab question that was on paper 2. So you should really be studying your lab book for the exam for paper 2 as well. You want to refresh your labs. And also there are some labs that you never did at your school, but CXC had it in the syllabus that these topics had labs associated. And they assumed that once they wrote it in the syllabus, you should have researched it. And so they put it on the exam. So you want to make sure you get as much of experimental skills as possible from the labs from your school and on that paper 2 exam. Paper 1, the multiple choice, has 60 multiple choice questions. The bulk of the multiple choice tests knowledge and comprehension and 10 tests use of knowledge. Also, on paper 2, 35% of paper 2 tests knowledge and comprehension. So basically, knowledge and comprehension will make up 43% of your final grade, which is how well you recall information, right? Then now, between paper 1 and paper 2, and the SBAs also, you actually have 37% to earn for use of knowledge, and experimental skills comes to approximately 20%. So chemistry has a slightly slower weighting for knowledge and comprehension than for biology. Biology had a 48% of your grade was knowledge and comprehension. Chemistry is 5 points less, which is 43, and they added 5 points use of knowledge in chemistry. So it's 37% here, and it was 32% in biology. And the experimental skills is basically about the same. So when you have this in mind now, you want to optimize on your experimental skills. Knowledge and comprehension will be what you retain, but you definitely have to practice, guys. For the use of knowledge, you're not going to stand a chance if you weren't practicing in chemistry. Whereas you can probably try it with biology, don't try it with chemistry. And so here it's showing you the different skills and what they mean. So when they say knowledge, the CXC explains what they mean. And what do they mean by comprehension? Every word that they have, they give a meaning in the syllabus. And also, what do they test? Well, what are you graded for in use of knowledge? They tell you application, analysis and interpretation, synthesis, evaluation, and environment. So you can read that through. And then they tell you for the experimental skills, it's the skills of observation, recording, reporting, drawing, manipulation, measurement, planning, and designing. So each one of the profiles, they are explaining what are the things they're looking for in each profile. So guys, for chemistry, you want to dedicate no less than 3 hours per week for preparation for the exam. And for chemistry, you have to do questions, both essay questions and multiple choice on each topic. Every topic. And that's why even our program, we are structured like that. Every single week from the very get-go, once you start, anything you learn, you're going to get the past papers on that to complete. We'll show you, demonstrate to you how to do it, and then ask you to do it and send it in to be marked. And we do the same for multiple choice. Now, if you are attentive in class and you take the extra effort to do the questions every week, usually that's fine. That's usually all you need, right? And of course, if you needed to review some of the grade 10, you review it. But usually, if you can develop that discipline of doing the questions weekly, guys, that's usually what you need. Because what it would mean is that by the time you get to the end of April, you would have done about 10 years of past papers. But it doesn't feel so taxing because you did it 1 week at a time. And the way and for it not to stress you, we only recommend or we give you questions based on what you just learned. So if you're learning a topic, if you're learning acid bases and salts this week, then we'll only look for acid bases and salts questions to give you. We're not going to give you a question that has some electrolysis in it and you didn't learn that yet, because that usually stresses you out when you are asked your examiner on something you were not prepared for. So make sure you prepare you and then ask you for what you're prepared for. And you do it one step at a time. Try not to go in with less than 15% of your lab grades out of the 20. And this is just a reminder again of the CXC final grade. Paper 1 has 60 multiple choice questions, lasts 1 to 15 minutes. Paper 2 was for 2 hours and 30 minutes, has 1 SBA question, 2 structured questions, and 3 extended response. And paper 3 is the SBA. So this is a profile of a student who managed to obtain a grade 1. Knowledge and comprehension, they got an A. Use of knowledge, they got an A. Experimental skills got an A. So the student mastered all aspects. So the student got a grade 1. Persons can get a grade 1 even if they got a B in experimental skills. So you can get a grade 1 with a B in experimental skill. But usually you have to get an A in use of knowledge to get a 1 in chemistry. I rarely see where persons get a B and get a 1. Right? Make sure you have your own personal copy of the syllabus. Tick off the objectives that were covered each week in the syllabus. And remember, this is how the syllabus is structured. It tells you the objective, it explains it. And if CXC thinks a lab can be done on that objective, it will suggest it as a practical activity. But the critical thing is this: even if your school does not do this suggested practical activity, it still means that you have to know about it. You have to look it up on YouTube, because it can very well come in the paper 2 exam on the lab question there, because they expect that any suggested practical activity that they wrote in the syllabus, you should be aware of it. So please read ahead on your experiments. Watch YouTube videos to get visual insight of your topics and your labs. For example, YouTube has the labs there already for any topic, so you can watch it before you actually do the physical lab. Or if you never do the physical lab, you still watch it and make sure that you have seen it, so that if you're asked a question in the paper, you can at least give something sensible. So guys, this is what you have to cover in order to do your CXC exam. You have to cover your 29 topics, section A, B, and C. You want to score well in your experiments, and that will allow you to be sufficiently prepared. I would like to know if you have any questions on what we've covered today. And if you have no questions while you're waiting, I want to ask you a question, and you can type it in the chat for me. And let me ask you, see how much you remember about how you're going to be graded. What percentage of your final CXC grade does use of knowledge, what percentage does use of knowledge contribute? Let me see you type. And I'm seeing your answers. All right. So most of us know that it's 37%. All right. And some of this, it is 37% comes from the multiple choice paper. 10 points come from that. And it comes from paper 2, and even comes from labs as well. All right. So you have to make sure you're earning that use of knowledge. Right. Another thing I want to ask, if you remember, which I did mention at the beginning that there are 3 topics that are the pillars of chemistry. 3 topics that are the foundational pillars of chemistry. I'm going to go back to that slide, because you may not remember the topics off the top of your head, but I want to know if you can even identify the numbers for the ones that I said you can't survive without them. So from this list, which numbers I said were the ones that chemistry was built on? All right, so I stressed 3, 4, 5. But you can't, well, you need each one to teach you the next one. So you need atomic structure to understand periodic table. You need periodic table to understand structure and bonding. And from structure and bonding, you have to get that, because if you don't get structure and bonding, everything else after that is going down the gully. All right, structure and bonding, because everything else you're going to see in chemistry is going to be a compound or an element. So you must understand how atoms bond to each other. And you cannot understand structure and bonding if you never understood the periodic table or atomic structure. So I would say to you that if you are feeling any way shaky or doubtful in these 3 topics, review before you start your 5th form classes. Get that fine and you'll be confident to do the rest of the topics. So guys, we're going to stop here. Do you have any questions? Any questions? All right, so thank you so much for participating in our grade 1 roadmap seminar. I hope you have been empowered with the scope of what you have to do in the next 34 weeks for your exam. All right, and all the best in your exams. We do start our classes at extra time next Saturday for persons who would like extra help. But I wish you all the best. Okay, guys. Bye, and thank you for coming.
Excuse me, miss.
Yes.
Do you have any classes during the week, like during weekdays?
Not for chemistry. It's on Saturdays or Sundays.
But for biology?
Biology is on a Monday afternoon,
Oh, at what time?
5 p.m.
All right, miss.
Okay? All right.
All this, all this.
All
Later,
right.
miss.
Okay. Bye, guys.